equations. Alright, so d over dr. Right, so again our assumptions are same as the wire. Okay, so d dt. So this one is a ceramic. Okay, so dr equals to 0. The steady state, no agent. Okay, so remember that. Okay, so ceramic, so only the agent is appears in the wire. So here no agent. Okay, so steady state. Okay, so you do the integration. Do the integrations. So R dt ceramic. Okay, so divide by dr equals to C1. Okay, so you rearrange the equation. So dt ceramic. Okay, so over dr equals to C1 over R. Alright, so the integrations dt ceramic. Okay, so equals to, okay, so C1 ln R. Okay, so ln R plus C2. Okay, so you have two conditions. Okay, so when heat temperatures, okay, so when R1, okay, so when there is the R1, alright, so the temperature is T1. Okay, so I make assumptions, I name as T1. So which means that, okay, so at this point, so inner one, so R1, okay, so or the R, okay, so temperature T1. Alright, so here second surface, so temperature surface. Okay, so temperatures at, okay, so if you want to put it at the R, okay, if you want to put it at yes, like if you R2, okay, so R2 temperature is equals to Ts or equivalent to 45 degrees Celsius. This one you can simply put. So some students say I want to put T2. You can put T2. Just a labeling. Okay, so you know that that indicate the temperature at the surface enough already. Okay, so in these cases I name it. Okay, so one is T1. Okay, so in the middle cylinder. Okay, so outer cylinder. So I name it as T2. TS. Okay, so when R equals to R1, alright, so I name it as T. Okay, so the temperature here we use is T1. Okay, so T1 equals to C1 ln R1 plus C2. Okay, so I rearrange the equation. So C2 equals to T1 minus C1 ln R1. First equations. Okay, so second conditions when R equals to R2. Okay, so this one T equals to T1. Alright, so T equals to Ts. Okay, so from this equation, so I come up with the equation. So Ts equals to C1 ln R2 plus C2. Rearrange the equation. C2 equals to Ts minus C1 ln R2. Okay, so solve the two equations. Alright, so T1 minus C1 ln R1 equivalent to Ts C1 ln R2. I take out the C1. Okay, so I bring this here I bring this C1 to another side. Okay, so it's ln 2 minus ln R1 equivalent to PS minus D1. Okay, so your C1 equals to DS D1 ln, so this is negative, right? So actually equivalent to divide. You get your C1. Okay, so you get your C1, then dividing on C2. Okay, so C2 equals to PS minus C1 is PS minus D1 ln R2 R1 ln R2. Okay, so you get your C1, you get your C2, substitute inside the equation. Alright? Substitute, so now equations PR equals to C1 PS D1 ln R2 R1 ln R. Okay, so plus, so this is C2, C2 is PS D1 ln R2. Okay, so these two are the same. Okay, so these two are the same. Okay, so here, okay, so I simplify the equations. So now become PR. Okay, so PS removed. Okay, can put a plus. Okay, so PS minus D1. Okay, so PS minus D1, so this one is R2 R1. Okay, so ln R1. Okay, so minus ln R2. So equivalent to ln R divided R2. PR is the general equations at any point. So that's why I put an R. Unknown one. Okay, so remain R dot R minus log R2. Not yet finished because they said determine the temperature. Now you only get the general equation. Okay, so supposingly you can use the equations. Okay, so these equations to get the temperature. Okay, but then T1 unknown, TR also unknown. TR unknown, T1 unknown.
T1 equals to T1.
TR equals to
T1.
T1. Okay. Then you rearrange, then you get the answer. Okay, so you can make, because the question said determine the temperature at the center. Okay, so first center, so you assume that the TR, okay, so now equals to T1. You substitute inside the equations. So surface temperature, you know. So R is the one you want to know. Okay, so R because at the center, so here I name it as R1. So your R equals to R1. Okay, you start inside, you get the T1. Because they want to find the temperature at this center. Okay, at this center, so temperatures. Okay, so this temperature at any point. Okay, so at temperature at the point you want to find. So now I want to find T1. So now I replace TR equals to T1. Okay, so R2 known, R1 you known. So now R unknown. Okay, so R is the point you want to find. So now you want to find at the middle. Okay, so R equals to at this point. So R1. Okay, so then start inside, you get the answer. Then you need to be careful, so your R2, okay, so R2 is, okay, so inside they said they give you the radius is 0.2, okay, so here, so 0.2, so add another one thickness here, so 0.2 plus 0.5, okay, so here 0.5, so your R2 is 0.2 plus 0.5. So this question is very lucky they give you on radius. If let's say that they give you the R1, this is D1 diameter, so you need to divide. Okay, because they give you this is extra thickness. So R2 is 0.7 centimeter. Okay, R2 is 0.7, so R1 is 0.2. Okay, so now your R equals to R1, so it's equals to 0.2. Because some previously got students being cheated by the questions, so they give you, okay, so first they give you the diameter, so diameter here, so for example 15, right, so they say another thickness, so let's say 0.5. Okay, so here student directly plus cannot, you need to divide to the radius. If let's say you using the diameter, so here you need to plus 0.5. This place you need to plus another 0.5. So total you need to plus 1. Okay? So if let's say radius, then you directly plus.
That's the center.
They want to find two temperatures. One is at the center, so another at interface. So here this one is defining on interface. Two things. Temperature at the center, temperature at the interface. So which is at R1. So you're finding on the temperature. This one is at interface. Okay. So at the center you need to find using these equations. Okay, so this one you can use this. Okay, so now you get your T1 already. So you get your T1 already. So Ej you know. Okay, so R equals R1 you know. Center here R equals to 0. You find the R equals to 0, so then you get the answer. Because at the center is R equals to 0. You need to do the balik one. You find it on T1 first. Then find on the temperature at the center. Pardon? Question, right? You ask something, right? Look. You use these equations, okay, so because this is the interface, because this one is equations applicable for here only, R1 until R2. Okay, so in the middle here, you want to find the temperature. This temperature two ways. Either you use the wire, then you find on the T1. Okay, but this one, the center, you don't know. Center temperature, you don't know. So you cannot use the equation, the wire equations to get T1. Alright, so you need to use the second equations to get your T1 because around surface temperature you know already. So based on this equation, surface temperature you know already. So you can find T1. If let's say that the temperature of the middle you know, alright, you can directly use the equations here. T1 because in your equation, so you use T1. If T1 known, you can directly use this one. Since T1 unknown, so no choice, you need to use the surrounding one to get your T1. You get a T1 already, alright? So, but then you cannot use these equations to find your T center. Because this one only applicable for this layer only, for the ceramic. Okay, so at the center is the center of the wire. So you need to use these equations to get the temperature at the center. Can I? Understand? Okay, understand? Clear?
This one you want positive or negative, then I figure this positive, negative, we change it to become positive. Then I place it over here, then it become negative. So T1 minus T1 is equal to 0 already.
Supposedly it will become 0, This is in Kelvin.
In Kelvin also will be 0.
This Kelvin.
This one because T1, right? I put this one with the negative, I put here it become positive. And minus I multiply it over here it become positive. Then I place it over here it become negative again. So T1 minus T1
R1. So let's say here you said this is R1. So you do equal. You can also get the answer. Because at this point the temperature are the same. So you use equal 10. Okay, so you use equal 10. Because I think you get 0 degrees Celsius. Alright, so no choice, then you use the equal. You do these two equations equal. Because temperature at R1 here, okay, equals to temperature R1 here. 100% conversion. So this equals to this 10.
So this is 0.
I thought it's the same.
Same ah? 0 ah?
Try common.
Okay, if let's say you get 0, then another others method you need to use already. Okay, so if let's say you get this 0, also this one is 0. So another one method you can find the answer. Okay? So if let's say that okay. So another method you use. Because you also you get 0 degrees Celsius, right? Okay, so we are going to use the third method.
就是
Okay, so at the interface here. Okay, so at interface here, So it's actually the Q value for the wire. Okay, so equals to the Q for the ceramic. Okay, so negative K area, we assume the cross-sectional area are the same. Okay, so dt wire equals, okay, so equals to negative Ka. So the what area are the same, so I can cancel out. Okay, so dt ceramic divided by dr. Okay, so look at the equation. So dt wire. So this is wire, K wire and K ceramic are different. Okay, so ceramic are different. So previous equations, you get your dt. Okay, so what dt wire yesterday you get is negative E gen R over K 2K, right? Yesterday you get this, the K value dt over dr is this one, right? I think. Right?
Got constant.
So equals to negative K. So dt over dr just now we get is dt over dr just now we get is, I think ts t1, right?
C1
What?
C1 over R.
C1 C1 over R.
C1 over
R.
R.
R. Yes, R. D. C1 over R. C1 yes. Times 1 over R. Cái
Times over 1 over R.
sao? Cái là C1 này. Duy nhất là nhiều cái số nhá.
Then you substitute, you get the temperature. T1. Then these two can cancel, right? Oh no, elsewhere. If let's say the two methods, just now the two methods you cannot get, then you no choice, we need to use this one already. Okay, so you get your T1. Then you get your T1 already. Supposedly you should not get 0 lah. Okay, so substitute here. Then you get your R. You get your Ty ya. Temperature at the center. Okay, so you calculate the R equals to when R equals to 0, yeah? R equals to 0, so you get your temperature here. Okay, so this one, no choice, you need to try. So you using the equation and substitute the value, see whether you get or not. If you cannot get, then you use this method. So let's say that so this surface, okay, so this is wire. So another saturation, so the contact area are the same. This is this wire area for the wire is 2 pi dl. Alright, so cross sectional area also for the ceramic also pi dl. At that surface, at that plane, so the contact area are the same.
因为用它的 alternative method 找是吗？
要用它的 automatic method 找。
那个找不到，那个就找不到。第一个它写出来也找不到。
那些两那些就找不到，就是这个可以找到。
Okay, 100 plus 100 plus.
减 K 是什么原理？
可以是那个 constant conductivity 啊。
这个了。
一个是 for ceramic， 一个是 for wire。
Okay, we do one quiz. Do one quiz. Yes, question. I know. Yes, you need to convert.
哦，是每个啊，
怎么哪个啊？是 W是哪个
？CMQ 它不是一个 Q， 我要100。
Can I ask method? So either you use this one, okay, or you did use this one. Question asks you to calculate to the previous questions. If it's within the ceramic, then you use this equation. Within the ceramic, then you use this equation. It's between R1 and R2. Okay, so you use this one. Okay, so if let's say it's within the wire, so you use the wire. So this equation is only applicable for wire and also applicable for ceramic only. I posted the questions in the Google Classroom. T1 greater than T2, so you have two different things. T1 equals to T2, so these two values can equal. So actually, later you replace the T2 to equal T1 or T1 to T2. You come up with the general equation first. Do the integrations and something. Got that? The dimensions you experience uniform heat generation. So meaning that you have Egen.
No value.
No value. So all no values, just the equations only. So just put Egen and T1 100 plus. 100 plus. Degree Celsius. Right? Celsius or Kelvin? What is T1 you'll get? Haven't get ah? Haven't get ah? T1 is 149 point something. T2? Sorry, T center? The calculate T1 is 149 point something degrees Celsius. You need to convert the Egen you need to convert. Then the radius you need to convert. Okay. Get? Get? 100 plus? No. Hey, I worried leh. You 2.5 hours cannot finish it. One question more than 2 hours. Okay, value difference, right? Okay, 1 and 2.